Proyecto dedicado a la divulgación, formación y terapia psicológica. Consulta nuestros servicios en nuestra web y redes sociales.
What I'd like to do at this point is to describe a set of a body of research on verbal behavior that is about the functions of language. And you've talked about structure quite a bit, not so much about what language does. And of course, what language has got to be part of in some ways, it's social behavior. And as far as I can tell, I have not been able to come up with any function of language that is an irreducible function other than we came up with this really elegant way in which one individual can get another individual to do something. And some other organisms do a little of that, but we do it in an amazingly varied way. And we see it happening in politics, and we see it happening in all kinds of areas. I mean, it's one of the things that kept coming back to me as we went through our political turmoil in recent years was that the idea that language is rational is a very limited value when you see what politicians can do with words and how the words don't have to have any consistent relationships with the way things are in the world. So there's a body of research now in which people have been working with using reinforcement, shaping what people say. And it goes something like this. You have a kid pressing a button, and the kid's pressing the button fast when one light's on and pressing the button fast when another light's on. And that's what kids will do under a lot of circumstances. And then you have a hand puppet starts talking with the kid and saying, teach me how to play that game. And you get the kid to say something like, well, the way this one works is you got to press it a lot without stopping. And the way this one works is you got to press and wait and press and wait. And if the person doing this is successful in getting the kid to say that, that's what the kid begins to do. So that there seems to be this linkage between talk and doing things that is a very fundamental thing. It works with preschoolers. It works very soon after they become to the point where they're talking full sentences. Comes in somewhere between the ages of 2 and 4. It also works with college undergraduates. It works, and you can also find it in other places. Now, to me, and it does. So that's a thing that's really orthogonal to questions about whether what you're saying is grammatical or not. It's about how the behavior works. And it troubles me because it does suggest that if you have a group of people who talk only to each other and they all get each other talking in certain ways, that the group can begin doing things. And maybe some of the things that we worry about with religious extremism and all can be related to these kinds of phenomena. I wonder if you have any thoughts about these directions and these functions of language. Have you worked? And I know you have interest in politics as well. So
I say most of my life is devoted to these questions.
Yeah.
But these are totally separate. Oh,
I grant you that.
Of the nature and origin of language. There's some important things to remember about evolution, which are often overlooked. The process of evolution pays almost no attention to function. So if you schematically look at evolution, how does it work? You have some system, maybe bacteria, and some accidental event takes place which disrupts the system. Could be a mutation, could be genetic drift, could be gene transfer. It could be, in fact, sometimes is, one microorganism accidentally swallowing another, which happens to be what led to the development of eukaryotic complex cells, us. Otherwise, we'd all be bacteria if that hadn't happened. So you have some accidental event that takes place. Then nature comes along and develops the optimal analysis, the optimal structure for that new system, just the way physics determines that when bees poke through a substance, it becomes hexagons. They're not trying to make hexagons. It's physics that does that. And the same is true of evolution. So the first stage is just some random event. Second stage is nature structuring this in the optimal fashion. And the third stage is natural selection. Those that reproduce more tend to stick around. But at the second stage, constructing the system, nature hasn't any idea what the function is going to be.
Well, of course not.
Things are not created because of a function. So, for example, and that's true of everything, language and everything else. So I use my fingers to type, but nature had no knowledge of that when it developed fingers. And the same is true of evolution generally. So functions only appear at the third stage when you're getting reproductive success. Now, in the case of language, it looks as if the third stage was never reached, maybe because of lack of time. But as far as we know, all humans, no matter how separate they are, have exactly the same faculty of language and cognitive faculties generally. It seems like humans have very little genetic variation, very slight. And the faculty of language, other cognitive capacities seem to be shared completely. So it looks as if the third stage of natural selection was never reached for language, only the second stage of constructing the simplest possible system once some disruption took place. So a possible scenario is that some minor rewiring of the brain yielded recursive enumeration of digital infinity. Then nature constructed the simplest possible system for the internal language, the language of thought. Then when you get to the externalization, you have to ask, how do you relate this to systems that have been around for millions of years and have nothing to do with language? And that's where you get the phonetic questions and the questions of gesture and sign and so on. But remember, they are not linguistic questions. They are questions about systems that have no connection with language. But we have to basically make a distinction that actually goes back to Aristotle between possession of knowledge and use of knowledge. Those are very different things. Study of the structure and nature of a system is possession. Use is a different story, and it involves all sorts of other things. So these are just two different enterprises. It's not a matter of better or worse. Two different enterprises that have to be separated from one another.
But for me, there's still one major thing left out. I mean, whatever is going on inside, there's still got to be an environment. I mean, there are things out there, we look at them, and then we say their names, or we say something about these other kinds of things. There's got to be a way in which the environment then determines some of the things we have to say. I mean, it's one thing for them for us to talk grammatically, but it's something else to have something to say about what's going on.
That's right.
And there, I think we need some story about how the environment is doing things. Now, one thing we do know is that some of the organization of the brain is determined by the environment. So, for example, well, I'll take an example that I know pretty well because my son's in biology and he's worked with a little creature called the star-nosed mole. And the star-nosed mole has these rays. Actually, I could, if we do have a share screen here, so let me just, I'll put this one up.
Well, we have very good examples for humans. Okay.
It was screen sharing. Let's see. I'm trying to I'm not sure.
Well, we don't have to. We don't have to because there
well,
are.
Anyway, don't worry. It's the Sarna's mole has these 12 rays on these 11 rays on each side of its head, and it's a tactile organ, and it goes down its tunnels and all, and it's feeling for little insects and tiny things. But if you then look at the projection areas on the cortex, there are stripes corresponding to each of these rays. And so if for the 11 stripes on the right side, there are 11 stripes on the left cortex. For the 11 stripes on the other side, there's if you capture one, though, that happens to have developed with 12 stripes or with 10 stripes, that's the number of stripes you find on the cortex. So the cortex and these divisions between the separate rays, their representation on the cortex is driven by what's out there in the periphery. And when I asked him, by the way, what he was studying, he told me, then I study homunculi, which was a kind of an interesting thing for he told us as a behavior person. So the boundaries are created by the periphery, and so this leads me to wonder how much of this organization then is driven by environments, not simply by the genetic history.
Yeah, actually, a lot is known about this in classic work. Including human vision.
Of course, there's the human homunculus and the fingers and the arm and so forth.
Classic studies by Hubel and Wiesel back in the late 50s, for which
they were working when I was a graduate student, and
they received the Nobel Prize for showing how in the mammalian visual cortex, the first few weeks of life yield stimuli which determine the structure of the striate cortex, the peripheral processing. So if you present a kitten, if you don't present a kitten with structured stimuli, it'll be blind for the rest of its life. The relevant parts of the peripheral visual cortex just don't develop. If you give it horizontal lines, it'll be attuned in later life to recognizing horizontal lines, vertical lines otherwise. So there's been a lot of work on that, particularly the visual cortex, but it works for all systems. The very early period of life does affect the structure of the neural system. And there may be some epigenetic effects later. They're pretty hard to detect, but they're possibly there. But these don't really affect the question that we're discussing. The fundamental for language and other cognitive systems, as far as we know anything about them, the basic structure is given innately. There are modifications that come from interactions with the environment. But if we're looking at the evolution of the system, these environmental effects are much later. The basic story is you get a random event which disrupted the system, say bacteria or other systems, then restructuring in the optimal fashion, then possible effects of natural selection, which for humans never seem to have happened because maybe there was not enough time. It's a very brief period that we're talking about. These numbers, like a couple 100,000 years, are an eye blink in evolutionary history. So we're talking about something almost instantaneous. And if we put aside all the just so stories, all we know about the evolution is there are apparently the human language faculty and everything goes along with it, faculty of thought and so on, came along with modern humans, roughly on the order of 200,000 to 300,000 years ago. It's apparently never changed since, after the separation, which was not long after, it remains the same. And there's basically nothing like it before. It's been well recognized by evolutionary biologists.
Do you
Theodore
think it's going to turn out it was a lethal mutation in the direction in which we're going in politics?
I think there's very good reason to believe that. There's very good reason to believe that higher intelligence altogether, what we call higher intelligence, is a lethal mutation. Fermi's paradox bears on this. You know what this is? Enrico Fermi, great astrophysicist, asked one simple question: where are they? How come, with all the massive efforts to find some sign of intelligent life somewhere, we come up with nothing? He recognized, as a distinguished astrophysicist, that there's innumerable number of planets that share enough of the properties of Earth so that they could have developed intelligent life. So why don't we hear anything from them? Well, when he brought this question up, John von Neumann, great mathematician, apparently answered that any intelligent life would develop nuclear energy and they would destroy themselves by radiation. So they're not around. Others have speculated otherwise. But if we look at current human behavior, the way we're dealing with the impending climate crisis, for example, it does look as if there's an unbridgeable gap between our technical capacity to destroy and our moral capacity to overcome it. And that might be the reason why we never hear any indication of any other intelligent life. It's just a lethal mutation. We're trying to show that right now.
Gracias por ver este vídeo, os dejamos por aquí un enlace a nuestra última formación y por aquí algunos vídeos que os pueden resultar de interés. Si estáis buscando ayuda psicológica, también podéis mirar en la descripción del vídeo, donde encontraréis nuestra web y podréis solicitar asistencia terapéutica de un profesional confiable y que os ofrecerá ayuda psicológica basada en evidencia científica.